friends, welcome to Coding Garden. In this video, I am going to create an Express API with TypeScript. So if you watched the last video, I gave a basic introduction to all of the things you'll need to know in TypeScript in order to get started with TypeScript. It wasn't a deep dive, it was really just all of the base understanding of TypeScript and really enough to get you started and enough to allow you to understand what we're going to do here when we create this Express API with TypeScript. Now, in this GitHub repo, I do have links to all of the stuff we talked about last time in terms of how things work. But down here, I talk about the fact that we're going to use a project generator. Now, we could start from scratch, but then this video would be an hour longer unnecessarily. So I'll point you to the GitHub repo that I have called Express API Starter TS. So this is a super basic starter template for an Express API with TypeScript. This doesn't assume any database. This doesn't add a bunch of extra stuff. This is only the things you need and nothing more for a basic Express API with TypeScript. And then you can put all of the extra stuff on top of it that you need to. And that's what we're going to do today. So if we run this command in a directory, that's going to clone this repo down, and then we can get coding from there. And I will give you a quick rundown of all the files that are in there. So I'm doing this from within the intro to TypeScript repo. So I'm actually going to make an examples folder first, and then inside of that examples folder, I'm going to run this command. And then the directory I'm just going to call this Express API. And so this will essentially clone down that repo, do an npm install of the dependencies, and then it's ready to go. So now if I go into Express API and do npm run dev, we have ourselves a basic Express API written with TypeScript running on port 5000. Great, great. Let's take a look at the code. So if you look at the README, I talk about some of the dependencies we have in here. So some of the middlewares we have for like error logging and header protection and .env loading and cores, and then also some of the development dependencies we use as well. I would say the main thing you need to worry about in the root folder is probably the package.json, if anything. This is where your dependencies are going to get listed if you want to add more, and you could change the start scripts. But pretty much all of these other files are just configuration files that you can leave as is. If you look at the tsconfig file, this is where you could add more TypeScript settings if you wanted to, but these are some sensible defaults. Essentially, we're targeting ESNext. We're using common.js. We have an output directory of dist. And we're including all TypeScript files in the source directory and TypeScript files in the test directory. The test directory right now just has super basic tests, and it's using Jest and a thing called supertest. So essentially, we can load in our Express app and then run requests against it and then expect against the responses to make sure that it's responding in the right way. And then if you take a look in the source directory, we have our index.ts. This is our main entry point. So it brings in our Express app and then starts it on a specific port. If you look at app.ts, this is our Express app. It loads all the middlewares, has just a basic response handler. And then we have an API router where all of our API routes get loaded. And then we have a couple of middlewares as well. So if you look in the middlewares file, this has a middleware which handles when there's a route that is not found. And then this has also an error handler, which is going to be our catch-all error handler. So any errors that happen will eventually all make it to this same place. And we're going to handle all of those errors in one spot. Okay, if you look in the API folder, this is where we're going to put our routers. If you look at index.ts, this is just the main one, and then it's loading an example router emojis. That just returns an array of emojis. And if you look at app.ts, we show where this all starts. So /API/v1 loads the API router. The API router then loads the emojis router. And so that means we can access this at API v1 emojis. So if we make a request to API v1/emojis, there we go, we get our emojis back. But that's just a quick whirlwind overview of everything. The first thing we'll do is just talk about where we're actually using TypeScript right now. So if you take a look at app.ts, you can see there's some weird stuff going on right here. And this is essentially describing what the response of this specific request handler is going to be. So message response is an interface I defined that is just describing an object that has a message string. So this is in the interfaces folder. It's just a super basic interface. It describes an object with a message property that is a string. And so what I'm saying right here is when a GET request comes into my app on the slash route, I am going to be responding with something that is of this interface message response. And where this is handy is now when I do res.json, I'm going to get TypeScript support. So if I try to specify values here that are not on that interface, I get a TypeScript error. So this tells me that banana string message string is not assignable to parameter of type message response. So this right here is instantly giving us the TypeScript support that we want, because it's helping us make sure that we're passing in the right things. And so essentially every API handler we create, we're going to create an interface that describes the response. There's some other arguments that go in here as well. The first one actually defines the params, or the parameters in the URL. And so later on, when we show an example of like get a to-do by ID, we're going to define an interface that says our params should have an ID property of type string. Right now, this is saying that we don't have any params at all. So if I do rec.params, I get no type completion because I've told it that there shouldn't be anything on here. It should just be an empty object. So it doesn't autocomplete any properties. This is really the benefit of using TypeScript here. Now, I'm going to show two ways of doing this. You can do it on the handler itself using the brackets. Basically, this get function is defined as a generic function, and we're defining the types here. The other way to do it is to specify it on the specific request and response objects. But I'll show that when we get there. OK, before we install dependencies, I just want to talk about how you can find dependencies for your TypeScript project. So if you take a look on the TypeScript Lang website, they have a search page where you can search through modules to see what's available. So we specifically are going to be using MongoDB. And so if I search MongoDB on here, this tells me that all I have to do is install MongoDB, and it already has the types built in. Another way to tell this is if you look up the package on npm, you'll see a little TypeScript icon next to the package. And if you see that, that means that you only have to install that package. You don't have to install any extra types or anything like that. We're also going to be installing a library called Zod, and it is written in TypeScript, so it supports TypeScript. But an example of something that actually doesn't have built-in TypeScript is Express. So if you search for Express, you'll see that it actually wants you to install two different things. And as a part of this template, I've already done that for you. So if you look in the package.json, we have Express as a dependency, but we also have types Express as a dev dependency. And we also have the types for our cores module and for Morgan all as dev dependencies. But if I were to search for Express on this website, it does tell me that, hey, you need to install this separate types package. And if you look at Express on npm, you can see that it doesn't have a solid blue box. These have solid blue. This one's not solid blue. And this tells me that I need to install a separate type package. So that's good info to know. And it's also good info to know that all of these extra types come from a project called Definitely Typed. So if you're trying to use a JavaScript library that doesn't have TypeScript definitions built in, people have done the work of submitting those types to this project so that people can bring them into their own project without needing to make a pull request or modify the original project to include the types directly. So that's all we need to know about that. We're now going to install Zod and MongoDB, these two dependencies, because this is how we're going to interact with our database. So let's do it. So in this folder, I'm going to do an npm install of Zod and MongoDB. Great. And now we'll start to use it. So our first lesson comes in on how to structure our folders here. Because technically, I could create a folder here called like models. And then this directory could have like user.ts, like that's the user model. And then let's say we're making a to-do app, which we are. I guess I didn't mention that, but we have a to-do model. And then let's say we also have I don't know, the banana model. Right? That's all in that folder. And then we would also need API routes. So then we would have some folders over here. So we have like the banana routes over here, and then we have the to-do routes over here. And as your application starts to grow, this gets really messy. In that it's hard to bounce between these folders, especially if you're working on things of the same type, right? So let's say I need to update the banana model, and then I need to go back over and update the banana routes. Now I'm bouncing between folders. So the way I like to do this is to create a folder with all of the things for a given feature inside of it. And let me show you what I mean by that. So let me get rid of all this extra stuff. And so now in the API folder, I'm actually going to create a folder called to-dos. And all of the things related to to-dos are going to go in here. So it's going to have my router, my model and schema, any sort of validation, any custom functions. Everything related to to-dos are going to go in this specific folder. And also maybe even specific interfaces to to-dos are going to go in this folder. And that's nice because now when I'm working on to-dos, I can just go in this folder. And then later on, if I'm working on another feature, I can go to another folder. So we're going to start here. And I'm going to create a file called todo.model.ts. This is where we will define our basically an interface that describes the to-dos that we're going to be having in this API. And then we'll also set it up for a MongoDB collection. So to define our schema, we're going to use a thing called Zod. So I'm going to do import star as Z from Zod. So Zod is a schema validation library built in TypeScript, and it works really well with TypeScript. So if you've ever used Joy or what was that other one? Yup. If you've ever used Joy or Yup, it works in a very similar way. But what's cool about it is it can also generate TypeScript interfaces, and I'll show you what I mean by that. So first of all, let's describe a to-do using this library. So I'll say a to-do must be an object like this, and then a to-do has a content property that is a string. So if I do z.string, I now have a string validator. So this creates a validator. I can pass an object to it, and if the content property is missing or is not a string, it's going to throw an error. I can also have like a done property, and we'll make this a boolean. I can also do things to say like this must be at least length 1, so you can't pass in an empty string for content. So just like that, I've defined a validator for the to-dos that I'm going to be working with. Built in, I get this function called parse, and I can pass in an object like this. So let's say I try to pass in an object with a content property, content property, that is an empty string. The result I'm going to get back has the actual parsed value. And if the parsing fails, this will throw an error. And the error will say, hey, content was not long enough. So this is really great because now I can validate things coming into my API. Awesome. The other thing I want to be able to do is have an interface that describes this type, and we can do that with Zod as well. So if I say type to do is equal to z.infer type of to do, now I have an interface. Let's export. So I'll just say export default to do. But now to do is not only a validation function in a parser, it also is an interface. So I can use this interface when I'm working with my API responses, when I'm working with my database models to say that when I'm inserting here, it must have a property called content, that's a string, and a property called done, that's a boolean. So here we've set up our basic interface. For now, let's use it. So I won't even set up the DB stuff. Let's actually just create a to-do route that describes that it will respond with an array of to-dos. So let's do that now. So here in to-dos, I'm going to create a file called todo.route.ts. And really, while we're here, I'm going to pluralize this because we have todos.model. I'm also going to have todos.route. Cool. And this is where I'm going to define an express router. So we'll import in router, capital R router from express. We'll create ourselves a little to-do router like this, and then we'll export it like that. And now let's define a route. So let's define a route that returns an array of to-do items. So I'll say router.get. On the slash route, we get the request and the response, and then we're going to respond with an array. And we'll leave it just like that for now because I want to go ahead and add some types. So I mentioned earlier that there's another way of typing your request handler. You can specify it here. So I know that there are no route param, so I could do empty object. And then I know that I'm responding with a to-do, so I could import that to-do interface we've defined here. But I actually could say that I respond with an array of to-dos like that. So this is saying that this route will respond with an array of to-dos. Right now, I'm just responding with an empty array, but let's try putting some data in there. So if I say content, let's say wow, or let's say learn TypeScript like this. Right now, I'm getting an error because we're missing the done property. It's required in the type. And once I've fixed those type errors, then it comes back like that. Let me show you the other way to write this. We can write it using generics on the request and the response objects. So Express, the types in Express also give us access to response and request. And then we can use those here. So I can say that rec is of type request and that res is of type response. But these can also be generic, so I can pass in the params here. And let's see, the first argument is response body. So if I say to do array here, now we have typing here that says when I do res.json, it should be an array of to do items like that. So you can do it one way or the other. I think what we're probably going to do most is this, because we actually will define these functions in a separate file. And when we're in a separate file, we don't get the automatic inferred types from doing a .get. So for the most part, this is how we're going to be typing our requests and our responses. OK, let's test out this route. So our app should still be running. Yeah, it's still running on port 5000. And if I request API v1 to-dos, it was not found because we need to mount it. So that makes sense. So if I go over here to my API router, I need to pull in the to-dos router. So I'll say import to-dos from to-dos/to-dos route, and we'll use it. So I'll say router.use. On/to-dos, I want that specific route. And actually, I want to pluralize it as well. I want to do to-dos routes. I'm making a lot of changes here, but it's my app. I can do what I want. So I called that routes, and then that got updated to routes as well. Cool. So now that it's mounted here, I should be able to go to API v1 to-dos, and we get access to it here. Great. Quick aside, someone in the chat asked if it was possible to do default values on our schema here, and it is, and I think it makes sense to do it here. So we can say that the default value of done is actually false. And now it makes it so that I don't have to specify done, but it'll set it to false whenever it's parsing in the object. So I think that makes sense to do there. All right, the next thing we're going to do is write some tests for this basic route that we've written here. This repo comes generated with some tests, so you can see some examples in there. But what I'm going to do before we write our own tests is I'm going to restructure things. But just like I like to have things that are similar together, I actually like to put the tests there as well too. So I'm going to move away from a separate test folder and move into having the tests right next to the thing that they're testing. So this API.test just tests the main route that it returns the API response, and then this app.test just tests like the root get route And it also tests that we have a 404 not found. So now I can delete that test folder. And the way Jest works, so Jest is what we're using for our tests, like this. It will find any file that has the name test in it. So we don't need a separate test folder. This should still work. So I'm going to kill this for now and then just do an npm test. And it should still pick up all of those test files. And ideally, all of the tests are passing because I haven't changed anything. I've only added new things. Oh, so of all these test files, we do need to update their imports. Oh, these files are not saved. Save the files. When I dropped them into the folder, I believe VS Code updated those paths for me, but I, for whatever reason, didn't save the files. Great. So now we have some passing tests. Awesome. I think I do want to split these out, though. So if you look in the API tests, I had this test in there, and then I also have this example emojis test. First of all, let's just get rid of that emojis test, and then let's also just get rid of the emojis router. And so now the only router that we're dealing with is the todos router. Great. Let's run the test again. But I appreciate that. I appreciate that shark turn up. You said it like right after I did it. Save, 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 save. Okay. And then now I want a test file for my to-dos. So in the to-dos folder, I'm going to create another file. I'm going to call it todos.test.ts. And we'll copy this basic test here and then modify it to match what we're trying to do. In this case, we need to require 2 directories up to grab the app. Okay, so I'm going to describe a get of API v1 to-dos. And this should respond with an array of to-dos. So this library, supertest, the way it works is you basically wrap your Express app, and then you can poke and prod at it and make requests against it and then test against those requests. I will mention, like in terms of the setup that I have here, it is important to have your app, your Express app, defined and exported from its own file. You don't want to mix this with what we do in index because we want to be able to test the app, the Express app itself, standalone, separate from starting it up on a port. Because that allows us to do things like this. Now we can just take that standalone app, wrap it in supertest, and then do some things with it. So I want to make a request to API v1 to-dos. I want to get application JSON back. And then I want to expect that the content type has the word JSON in it. And then we'll do it like this. Expect that I get a 200 status code. And then I can just poke and prod at the response. I guess we could just test if it has a length property. So let's say expect response.body to have property length. So make sure that we're getting back an array as the body, and then expect response.body.length to be 1, because right now we're just returning an array with length 1. So right now you can see that like we have this done function, and technically I could call the done function right here, and that lets Jest know that I'm done doing all the stuff that I'm doing. The other thing we could do though is turn this into an async function, and then just return the call here like that. And now, because this returns a promise, the moment this resolves, Jest knows that I'm done with my test. So this is just a basic test that makes a request to the to-dos endpoint, makes sure that it has one thing inside of it, and then we also could do some expecting on the body, the first thing in the body itself. So expect that the first item in the array to have property content. And then also expect it to have property done. All right, let's run our tests, see what happens. Cool. And I have broken the cardinal rule of test-driven development in that I've written a passing test before seeing that it was failing. We could make it fail. We could make it fail. Just to know, just so we have our sanity here. That I actually am testing the right thing and it's doing what I expect it to be doing. So So in this case, the length of the response is 1. I was expecting it to be 2. It should actually be 1. Yeah. Yeah, and that's if we're doing TDD. We're not going to do TDD. We're gonna build out the routes, and then we're going to write the tests. So we're going to test after writing the code. We're not going to drive the code via the tests. But this is a basic test. It's a good starter. We're going to start working on other things, and then as we add each route, we'll come in here and write some tests for it as well. All right, let's set up the database connection. So you saw a little bit ago we installed MongoDB as a dependency. MongoDB has built-in support for TypeScript, and it's pretty good support. Let's get it going. So in my source directory, I'm going to create a file called db.ts, and this is where I'll set up the Mongo connection. And I'm going to import need client from MongoDB. And then, actually, no, I'm not client. It's something MongoDB client. Mongo client is what I need. And then I'll need to create an instance of a client. So I can say client equals a new Mongo client with my connection string. And in this case, I'm going to grab that from my environment variable. So let's say the Mongo URI is pulled from our process.env. Now, I've shown in some other tutorials basically how to build out like a config object and a config loader, so that way we're not pulling directly from the .env. This is going to be our only environment variable, so I'm going to do that here for now. But I will link up here or somewhere that describes the process of actually building out a config loader and a config object, so you're not directly accessing it from there. But regardless, we're going to put it in our .env, and then I can pass it in here. TypeScript was complaining because technically from the .env that could be undefined, but I'm just going to default it. Actually, I'll make the default value here, like localhost to do API, something like this. Okay, so that gives us back a client, and I'm going to export that. And then we also get back a database instance. So I'll do it like this. And one thing I found out today in my testing is that you actually don't have to do client.connect. So what you typically see in a lot of code is basically you await this promise and then you spin up your Express app and then you start your tests. What I found today is that you don't need to do this. You actually can just start accessing your database, and the first time you access a collection, it will automatically connect it to the database. So that's how we're going to do things here. I will attempt to deploy this API, and it's possible that when we deploy and when we're talking to a replica set instead of like a local DB, this might not work, but it should work. It should work for the most part. So that defines this, and then I do want to create a .env file as well. So I'm going to go ahead and then throw Mongo URI in my env sample. But I'm going to create a copy of this into a file called .env. And here's where I can put my actual Mongo URI. And I think it actually will just be this. I do believe I have MongoDB running locally, and it should attempt to connect to MongoDB connected on my machine. If you want to know how to do that, you can look up MongoDB install on a Mac, and you can install it with brew. There's essentially a brew tap, brew update, brew install you can run, and then you can get MongoDB running locally. You also could spin up a Docker container, or you could go to MongoDB Atlas, get like a remote connection URL and connect to that. For me, I'm just going to connect to my local MongoDB. Okay, now I am going to define the collection. So over here in my to-dos model, I'm going to import in that DB instance. So let's import DB from, go up 2 directories and then grab DB like that. And then we will say to-dos is db.collection of to-dos. So you pass in the collection name here, but it supports generic, so we can actually pass in a type. So right now, if I just do this, todos is a generic collection that will just return generic documents, and documents are just objects that can have any keys. But if I specifically type this and I say this is a collection of to do, because remember we created that type earlier. Now when I make queries against it, it's going to give me back typed information that have like these properties, and when I do inserts, it's going to make sure that I'm specifying those properties. Let's take a quick stretch. Okay, how do I want to do this? I think I want to do, instead of exporting default to do, can I do export type? Yeah, so I actually want this file to export two different things. It's going to export the to-do type itself and then also the collection type. So that's great. But now that I've done that, I will need to update my route, because before I was just importing the default export. So now I can specifically bring in to do, and then I'm also going to bring in to dos. And now let's query the database. Let's get it working. So I'm going to make this an async function. I'll say result is await todos dot find. I'm going to find all of them, and then I can respond with result dot to array. So that'll take the results and turn it into an array. Yep, and this is a good point. So what it's complaining about right now is when I return these to-dos from my database, they're going to have an underscore ID property because they're from the database. So that makes sense as well. I'm actually going to define another type in my model here. Let's call it to-do with ID. And this is just going to use the with ID helper from MongoDB. And you just pass a type in. And that basically just adds the underscore ID property to that type. And so now I have this type that I can use in my route. So over here, I can now say that this should respond with an array of to-do with ID. And we will pull that in here as well. Now this is complaining. Did I forget to use await? I guess I did. I didn't know I'd have to do that. So I can say to-dos is await result.toArray, and then we'll pass that in here. It's good to go. Okay, so I'm going to run my tests. The tests should fail because there's nothing in my database, but it also could fail if it can't connect the database. Let's see. Invalid scheme, expected connection string. Yeah, so right now, I didn't do the MongoDB : // Let's make sure I do that. So in my .env, we'll put that there. In my env sample, we'll have that as well. And then the default value over here, we'll do that as well. All right, let's test it now. Nice. So it's connecting to the database, but right now the data we're getting back from the database is nothing because there's nothing in the database. So we should update our tests. And I think that that technically counts as a failing test. We have a failing test. We now need to update the code accordingly. And basically, when these tests run, I am going to run them against basically an empty collection. So I'm going to do a beforeAll, where I drop the entire collection before the tests. So that way, it's more predictable as to what I'm testing against. So before everything, we can do todos.drop like this. So completely drop the collection, and then now I should just expect that length to be 0 on the initial get. This should be a passing test. Nice. Nice. It failed. Why did it fail? Mongo server error, namespace not found. I'm going to search the web for this error because I have never seen it before. Oh, that's probably the case. Yeah, so I'm trying to drop the collection that has nothing in it. I'm performing actions on collections that don't... Cool, cool, cool. That's actually perfectly fine. I really just want to try catch this then. And then swallow the error. Yeah, that's it. That's it. Because basically, the collection doesn't even exist. There's nothing in it because it's a brand new database. So that makes sense. Awesome. So we have our initial to-do collection. It's completely typed. We have our initial route that's also typed. What I want to do now is I want to fix this error in our tests. Basically, after all the tests are done running, we need to disconnect from the database. So the connection to the database is automatic, but the the closing of that connection is not automatic. So we need to get that working. We can do that in our Jest config. There's a few properties where we can specify a file to run after all of the tests. I think it's like an env. Set up files after env. I think this is the one. And then I'm going to create a file with this name in my source directory, like this. So this should run after all of the tests have run. And what I want to do in here is say global.afterAll. So after all the tests, we want to close the database connection. And this is where I can do db, or not db, client.close. And we'll await that. And so this should run after all of the tests have completed, which will close the database connection and get rid of this detect open handles thing. Yes. All right. We've got some passing tests. So Milin is asking the question, what is the difference between Jest and supertest? You can see that both of these are dev dependencies. And then also because we're using TypeScript, we actually have TS Jest, which lets us write our tests in TypeScript, and then they can be run through Jest. But Jest is our test runner and expectation library. So when you look in one of these test files, all of the things associated with running the tests and running the expectations, all of those come from Jest. So beforeAll, describe, it, expect, right here, all of that's coming from Jest. So all of that's built into Jest. The things we're specifically using from supertest is this. So we wrap our Express app in requests, that's supertest. And now these chained functions, these are expectations and methods we can call that come from supertest. But you can see that I'm kind of combining supertest expectations with Jest expectations. And you can mix and match. I mean, technically you don't have to do any expectations from supertest. You could do them all with Jest. Like I could do expect response dot status code to be 200. Like these two are equivalent, but I think I just got so used to using supertest and using its expectations, but you could do it either way. But that's the only overlap between the two. For the most part, supertest is all about making the request to your Express app, and then Jest is about running the tests themselves. Okay. At this point, I'd like to do a little bit of refactoring before we move any further in creating this API. I essentially want to take this handler and put it in its own file. And there are a lot of different ways you could go about this. Like if you've ever worked in an app before and you see that it's following a model view controller, typically they might call that the controller file, and then the controller has all of these functions inside of it. I'm just going to call it handlers. So I'm going to create a file called todos.handlers.ts. And then essentially all of the functions that I need to run in here are going to be specified in that file. So I'm going to pull this out, and this is going to be something like to-do handlers.findAll. And then over here, I can define this function, call it findAll, and then export it. We need to bring in the request and response types from Express. And then we also need to bring in to-dos. So this file all of a sudden gets a little bit simpler, and then over here is where we're doing the hard work. And then I need to import to-do handlers here. So I can say import star as to-do handlers from to-do.handlers, like that. And this should still work. I've essentially just made this file a little bit more manageable because we're going to add a few other routes in here as well. And and then this is going to have our basically like our business logic. Okay, in terms of what should I call this file, or what should this be controllers? Should it be handlers? What should I call it? Often it's called controllers, but typically when you call it a controllers, you also have one more file that's really like the service, and then the controller actually calls the service. That's just more levels of abstraction. We could do that. I'm not going to do that. I'm going to keep it simple and have this here. But the reason you would want to do something like that is right now I'm essentially coupling my database access and my express request and response handling together. So in the future, if I wanted to move away from Express and let's say use Fastify, it would take a lot of refactoring, because right now I'm explicitly using the request and the response from Express, and I'm intermingling that with my database access. Whereas you could extract all of the database access stuff into a file called a service, and then you could have your controller, which then maps the request and the response to the service. And so in the future, if I ever wanted to change to some other framework, I could do that. I'm not going to do that today. We're just going to go this level of abstraction, but I will point you to this GitHub repo. It's called Node.js Best Practices. And one of the first things it talks about is layering your components, keep the web layer within its boundaries. And I'll show you this animation that they have down here. So by default, you can see that this database access is just passing in the request, which comes from Express, and now it's basically tightly coupling database access and Express. And so DAL stands for data access layer. That's another concept you'll typically see. So instead of a service, you might call it a data access layer. But right now, these functions are using rec from Express. And what they're saying is don't do that. You can abstract it more so that they're not tightly coupled. Instead, you can create this context object, which picks off the things from the request that you need, and then pass that into your data access layer. And that basically decouples them, so if in the future you want to swap one or the other out, you can do that. Like I said, I'm not going to do that. I'm going to intermingle them, but that is like an architecture pattern, a design pattern that you could follow if you wanted to. Okay, we've extracted it to this file. The next thing I want to do is error handling. Because right now, if an error happens, my Express API would actually just hang up. So let's do this. Let's make it so that my database doesn't actually connect. So I'm going to connect to a non-existent server. And the request should fail now, but let's see. So I'm going to run this in dev. We'll go to localhost 5000/todos, and now it's just spinning. And if I look in the console, I don't see any errors. This is actually just like an uncaught error. I think at some point it's probably going to time out because it can't connect to the database. But if it does error out, I might not even see that in the browser here. And that's because I'm not catching that error. So let's catch the error, or actually do something with the error. So I showed at the beginning that we have a generalized error handler. So if you look in the app.ts file, on line 28, we say app.use middlewares.errorhandler. Essentially, you always want your error handler to be the last thing registered. So all of your other routes are registered up here, all of your middlewares. The error handler is the very last thing. And if any route handler or middleware calls the next function with an error object, the error handler is what is going to get called. So you can see that we get access to the error in here. So essentially what I can do over here is I can wrap this in a try-catch. And then if it throws an error, I can call next with the error. And next is something that gets passed into the request handler here. So I can pass in next, which is of type next function. You can import next function from Express. So next, which is of type next function. And then if there's an error, call next with that error, like that. And so now if any shenanigans happen in my database access, it throws an error, and then now I call next with that error, and then we have generalized error handling here. It's going to put it into an object, pull off the message, add a stack trace. instead of manually sending back an error response right here. So this is really nice because all of our handlers can use this, and we can just do all of our generalized error handling in one spot. So now that I have that, let's see if it at least times out and maybe sends back an error. So now if I request this, I think eventually it will time out, but I don't know what the timeout actually is. Another way that we can just show this working is if we just throw an error. Something bad happened. And this is just simulating if this code were actually to throw an error. So now that we have that, if I make a request to this page, it just gets forwarded to the error handler. We see the message, and then we also see the stack trace. You can also see in that middleware that I turn off the stack trace if we're in production. That's a security precaution because you don't want to leak file names and line numbers in your error messages, because attackers and hackers could use this as information when they're trying to attack your server. So when we're in production, we don't show a stack trace at all. Okay, so that's generalized error handling. Let me revert back to our original database connection. And now we should be getting back an empty array from the database, which we are. Great. So at this point, let's create a createTodo handler. So over here in my API to-dos routes, I'm going to want a new route, which is going to be post on slash. So post to API v1 to-dos, and I'll do to-do handlers.createOne. And so now I want a createOne function in my handlers. It's going to look like this, so I'm just going to copy paste it. But now we'll rename it to createOne. And now it is actually going to respond with a to-do with ID. So after we create the to-do, it will respond with that. We can also now describe the incoming request body. So here I can say we don't have any request params, but we do have the to-do type here. And if you look at request, the first type argument is the params dictionary. So that's if you have a URL with params like ID in it, that's what that would be. But in our case, for this route, there are no params, so I did an empty object. And then the second argument is response body. So I actually did that wrong. So the second argument should be to do with ID. And then the third argument is the request body. So the incoming request to my server is going to look like this, a to-do with a content property and a done property. Now let's make it happen. So the first thing we want to do is we want to validate the incoming body. I'm going to do that in line here, and then I'm going to show you a way of where we can basically define middlewares that do the validation for us. So right now, I could do this. I could say await to-do.parse, singular to-do, .parse. Did we import to-do? In my model. Oh. I don't know when this happened, but I need to export that too. And so this is actually a feature of TypeScript. If a single file exports two things with the same name, one of them is a type and one of them is the actual thing, you're allowed to do that. So this is the schema validator, and then this is the actual type. I can call them the same thing, and then now I can use them interchangeably. So now to-do.parse is a thing. Cool, because that's coming from Zod. And the way this works is it parses the thing that you're the object that you're passing into it, and if there was no validation error, it will give you back that as an object, and then we can now use that object for our inserts. So we could say await to-dos dot create insert one. We specifically want to insert that in. This gives us back a result, or a insert result. And this is really our validate result. What is our insert result? It is an insert one result of that given type. So can I just res.json the insert result? But now I would have to say that this is responding with an insert one result of type to do, like that. Then I can change the return type here as well. Insert one result comes from MongoDB. And so now that responds like that. This should be all we need. Let's write a test for it. So if we go over to our tests, I now want to describe creating a to-do. So I'm going to copy paste this. So I'll say when I make a post request against API v1 to-dos, it should respond with an error if the to-do is invalid. So I now want to make a post request to API v1 to-dos. And then the way you actually send data is if you just do .send. And so this is the request body that I'm actually sending to the backend. In this case, let's try sending an object with the content completely empty, because this should fail validation because we said that content should have a minimum length of 1. And so here we want to, let's just do this to make it fail. We want it to fail. And right now this should fail because it should return a 500 status code, not a 200 status code. And actually we can also work on the status code we return because it's technically a validation error, which wouldn't be a 500 error, but we'll work up that next. So I'm just going to say, make sure the body has a property message and expecting 200. So now, if I run this test, it should fail because of the status code. That's what I'm expecting. So right now, it's responding with 500 status code, and I was expecting it to be a 200 status code. So let's handle that. Really what I want is if this error is a Zod error, then I want to set the status to be like 4 something, because 400, I believe, is a client error. There's a status code for when the body is invalid. We'll find that. I'll have to figure out how to check if it's a Zod error. Here we would do res.status of 400 bad request, something like that. I'm going to go look at the Zod documentation to see if they have any info on determining. That might be it. 422 unprocessable entity. I think that's the one I want. Like, you sent me something and it is not processable. Oh, do I just do... Oh, I did this wrong. So error instance of Zod error. Cool. So if there was a validation error, set the status code to 422. That's what I want. And then now in the test, I'll validate that the status was 422, and I get a message property in the response. I'm going to log that just so we see what it is. But it should be something about the content property not being long enough. So let's run the test. Nice. Test pass. And we can see we get this error response. So too small, string, path content, string must contain at least 1 character. Cool. I'm not going to worry about formatting these error messages, but if I were to format them, I would probably do it over here. So in the middleware, I could check to see, like, if the error is an instance of a Zod error, I'd have to make sure I import that in. Yep. Is an instance of Zod error, then error message is something like error dot issues. For each one, grab each issue and then grab each message. Something like that. I'm not going to do that here. I think the Zod errors are enough. And whenever we build a front end for this, we technically can parse these errors on the front end and then show this information on the front end as well. OK, so I'm going to leave those errors the same. We have passing tests. I'm going to remove this console log. Cool. So I'm going to write another test here. It responds with an inserted object. And so now we'll make the post request. We'll do learn TypeScript, and then we'll say done is false. Right now, I'll expect a 500 status code so that it fails. But eventually, it will have a content property and a done property. And it should actually also have an ID property. because it just got inserted into the database like this. So let's run the tests. The error I'm expecting is that status code is wrong. Yeah, so right now it's responding with 200, but we're expecting 500. So now if we expect 200, it should have an ID property, it should have content, and it should have done. And actually, I am just going to log so we can visually see it. But I guess we can do some more expectation here though. We could expect response.body.content to be learn TypeScript. Like that. Cool. Let's run our test now. Cool. Okay, so this is an issue. So the thing we were getting back from the insert is not what I expected. This is actually what MongoDB is giving us back. Yeah, and when MongoDB inserts the document, it will put the underscore ID property on it. So we actually need to use this inserted ID thing. So let's handle that. We can say if insert result dot. Yeah. So I thought we had the full thing, but we don't. So if it was not acknowledged, we need to throw an error. Something like error inserting to do. That's it. That's all we'll say. Error inserting. So if it wasn't acknowledged, we throw that error. That will get caught. It's not a Zod error, so then it's actually a 500 error, which makes sense because then it's more of like a server-side error, like something like the database went wrong in the database. But now I actually want to return the validated result along with the ID, which is the insert result dot inserted ID, like that. And now we want the to do with ID type as the response. That's what that should be. Because basically this MongoDB driver, whenever we do an insert, it doesn't give us back the thing that we inserted. It just gives us back whether or not it worked, and it gives us back the ID. And so I can respond with an object that has the ID and then also the data that was sent to the server and validated, because that's what most people would expect from the API. You get back what was created along with the ID. So that should fix that. Great. You got it. So this was mentioned by Nadoshi. Should we have a 201 status code? And I think that makes sense. So I looked it up, and 201 is the status code for something was created. And in this case, we created the thing in the database, so it does make sense to set that status code to 201. And then now we should expect status code 201. Cool. And I think Bajosi has a good point. Let's see how I wrote this. Good call. I actually want to call parse async. Yeah, because parse async does try to do things behind the scenes and then resolves a promise. Before, this was actually blocking. So, good call. We should make that parse async. I mean, it is... I get it, Eddie, because isn't it nice to just be able to run npm tests and be like, yeah, test pass. I guess my code's working. Instead of having to like click through multiple things, because like the other way we would test this is through Postman or Insomnia. We would manually have to make the HTTP requests, verify the response, and then every time we change something, we'd want to do that same thing. But now we're basically codifying that process into code, which is nice. So now I would like to refactor this and pull out a middleware function. So this validating of the incoming request body, I'm going to have to do that in at least two different places, right? I'm going to have to do that when I'm creating a to-do, and then also whenever I'm updating a to-do, because the request body is going to look the same in both cases. So what I'm going to do now is I'm going to write like a generalized way of defining how to validate the incoming request, and then we're going to move this into that validator. So first, let's take a look at todos.routes. And basically what I want to be able to do is I want to pass in something like validate request. like this. And if you're not familiar, in Express, essentially any one of these functions you pass in is a middleware function, and basically we can write code here that will look at the incoming request body. If it's good, call next and allow this handler to execute. But if it's not good, throw an error, and then this handler will never execute. So I want this magical validate request function to exist, and I want to be able to pass some options into it. And so in this scenario, I want validate request to validate the body. So I'm going to pass in an object where the body is to do. So this is our to do Zod schema, right? Now, as the request comes through, it should do that parse function. If it fails, throw an error. Otherwise, set the request body to be what the parsed value, and then call next. For other routes, I also want to be able to parse like the params, like the params in the URL, like ID or different things like that. And then in some scenarios, I might want to parse and validate the query string as well. For now, we're just going to handle the body. So I want a function called validate request that takes in the validators. Every Express middleware needs to be a function that takes in request, response, and next, right? So what we need to do from this is we need to return a function that takes in a request or a res and a next, like this. We can type these from Express, so we can call this request from Express, response from Express, and then also the next function. Like that. Great. Why is this complaining? Yeah, because they're never used. And then essentially what I want to do is a little try catch right here. So I want to say something like validators.body, and I want to pass in the request.body. And I probably want to do .parse because I'm going to expect these things to be like a Zod validator. So I probably want parse async. I want to get back the result and await it. And really, I just want to say rec.body equals that, like that. And then also this would be an async function. Cool. And if all was good, we can just call the next function, and that means it'll go on to the next thing. And if there was an error, we can call the next function with an error. We can do what we did earlier, and basically we can actually pull this out because now we're doing the parsing in the validator. And so over here, we can say, if that error was a Zod error, then set the response status to 422, which it should have been anyways. All right, now let's get this working. So we don't have this type. I want to define an interface called validators, or let's call this request validator. And it will have a body property, which is of type Zod object. Any Zod object, that. And then this will be optional because for some validators, I don't want to specify the body. Sometimes I only want to validate the params or only validate the query string. So we'll also have params and query, like this. And then the thing that we're passing in here is of type request validators. Yeah, and we can basically just wrap this in an if statement. So if we defined a validator for the body, then try to parse it with Zod, and then take that result and put it back onto the body. And then we can do the same thing with the rec.params. So if I say rec.params, rec.params equals validators.params, parse it. And then same thing with the query string. So rec.query will be validators.query, parse async with rec.query, like that. So now this is a general purpose error handler. Basically, we pass it an object that has a validator for any one of these things, and then it will look at the incoming request, and validate those things. But if there was an error, it's going to catch it and immediately halt. If there wasn't an error, then it will call next and go on to the next error handling function. And so now we're doing that right here, where we're essentially validating the incoming request body, making sure that it is of type to do. And so now let's actually move this into, we'll move validate requests into our middlewares file. So over here we have middlewares. Now let's define a function called that. So export validate request, like that. We'll move this interface into the interfaces folder. So over here, we'll call this request validators.ts, and we'll export default, pull these in. Oh, don't want that. I want to pull this in from Zod, like that. Cool. So we have request validator. In here now, instead of doing this, we want to import in from the middleware. So import star as middleware. Well, we could import star. Let's also let's just import the function. So we'll import validate request from middlewares. We don't need these types anymore. And now the code is working over here. So I just basically took the code I wrote right there, and then moved the function over here to middlewares. This needs to pull in that interface now from interfaces. And we should be good to go. But what we can do now is now in this to-do handlers.createOne, we can remove the validation, because now we know that the code will never make it here unless it was validated. And here I can just pass in rec.body. Rec.body. And it's actually safe to do this insert with rec.body because rec.body got overwritten by our middleware. So our middleware literally replaced the incoming body with the validated body. So over here, when we're passing that into our database, that's actually the validated version of it. And again, it's validated because it has to run through this function first. All right. Let's see if we did it correctly. We're going to run our tests. At this point, we just did a refactor. We didn't add any new features, so we would expect that all of the tests still pass. Cool. Looks like I have a console log laying around somewhere. Let's get rid of that. Yeah, let's get rid of this. But the tests do pass. All right, next up, let's create a get one single to-do route. So we already have that route that gets all of them. We want to create a route that gets one by ID, like this. And we'll say findOne. Now, in this case, we can add a request validator that basically just makes sure that ID is a string. So we can do a similar thing here. So when you request API v1 to-dos /some ID, I want to validate that the params are of type ID params. I'll have to create this interface, like params with ID, something like this. And so then I can have an interface that just defines an object with a property ID. So let's create that over here. So params with ID is an interface that has an ID which is of type string. And actually, I should define this with Zod. So instead of defining this as an interface, I define it with Zod, so that way I can pass it as the validator. So let's do this. We will import Zod, like so, and then we'll say export const params with ID equals z.object. And then that object has an ID, which is a string. I mean, really, it's actually a MongoDB object ID. So I technically could validate that. For now, we're just going to make sure that it's a string that is not empty. And then I also want the type. So params with ID is z.infer the type of params with ID, like that. So now I have this validator and interface, and we can use it here. So we'll import it in from interfaces. And now whenever a request comes into this route, we're going to validate that the ID here is a string, it isn't empty. Though I do want to look into validate object ID, because that would probably be better validation. We can basically prevent the DB lookup by making sure that this is a valid object ID. Cool. And then now we need the findOne handler. So over in this file, we're going to export a function, an async function called findOne. We get the rec, the res, and next. Do our little try catch here. And then we'll type these things. So this is a request. The params, we now have a type, which is params with ID. Request takes in the params dictionary, the response body. So findOne should respond with a to-do with ID. And then the request body should be empty. So there should be nothing in the request body. And then the response should be to do with ID, like that. And then this is the next function. Cool. So now we can do the work. So we'll say to-dos, which is our collection. We want to find one. We need to pass in the query. So I want to find one where the ID is rec.params.id. And the issue here is this is a string. It wants ID to be an object ID. So I should be able to pull in object ID from MongoDB there. So that imported object ID. And then I can say new object ID with rec.params.id, like that. Result is a to-do with ID. So I should just be able to do res.json for the result. However, result is possibly null, meaning they didn't find it in the database. And if we didn't find it in the database, we'll set the status code to 404 and say to-do not found. So if we didn't find it, we can do res.status 404. And then we'll do we'll throw a new error. And we'll say to do with ID rec.params.id not found, like that. Should be good. The one issue here is, like I said, we should be validating that the params ID is of type object ID. I'm not quite sure how we would do that with Zod just yet, so we'll figure that out after we test this route. So now let's write a test. And what I'm going to do is I'm going to write a test that uses the result of this previous test. So this test is the one that creates an object. So let's say I define a variable out here called ID, like this. And then I should get back from here response.body._ID, like that. And so now I can write a test that makes a request for that specific to-do. So get to-dos /ID responds with a single to-do. So now I want to make a GET request on API v1 to-dos / that specific ID that we got back from the creation. And then we can do some similar expectations here. So expect it to have all of these properties, and expect the content to be learn TypeScript. I guess we can also expect the ID to be that specific ID that we requested. Cool. So Again, I'm writing a test that's probably going to pass on the first try. We should also write a test for if the ID was not found. Yeah, so that passed. Let's say we do another test. Responds with a not found error. So if we try to request this, I want to expect a 404. However, we're probably going to get a 500 status code because this isn't a valid object ID. And then now I actually will call done right here. This doesn't want to return anything. Like that. This will be where we need to fix that object ID validation. So that gave it 200. Maybe I didn't save the file. Let's run the test one more time. Yeah, there we go. And that's what I was expecting. So the 500 status error is when it gets into this handler, it's trying to create an object ID with something that is not an object ID. So I now want to figure out how can we validate an object ID here with Zod. So let's figure that out. Refine. Yeah, I think that's what we want. And then we'll actually turn it into an object ID. And so refine gives us back the value. And we want to do a new object ID with that value. And then if that fails, then it's a, well, I guess really we kind of want to wrap this in a try-catch. How does refine work? Refinement functions should not throw. Instead, they should return a falsy value to signal failure. Ah, okay. So in this case, we will return false. That's what we want to do. So if it fails to parse, throw false. Okay. And then now that should be a Zod error and not a 500 error. Yeah. 422 unprocessable entity. So our to-do test should now expect that you requested some basically an invalid invalid ID. And if we look at the we can do this then. If we log the response body message, we should see a Zod error that says like not a valid. It wouldn't say valid object ID, but it would say, I don't know what it would say. Invalid input. Cool. But we can update that. Let's do. I think you can also pass in, it says you can pass in a message as the second argument, an object with a message property. Yeah. Invalid object ID. And now we should see the message invalid object ID. Nice. Nice. So this is testing something different. This is responds with an invalid object ID error. Like that. And then let me just steal an ID that won't be reused. like this, and then we can test for the not found. So it responds with a not found error, and then we'll request this one. The cool thing about Mongo object IDs are that they're actually time-based. So embedded in this is a way to get the time that the document was created, which also means that this won't be repeated in any new ones we create, because they're getting created in the future. So we'll expect this to be a 404. So this should be good. Yep. And then, I mean, if we do todos/2 or todos/3, we should see that same 422 response error, because the number 2 is not a valid object ID. Yeah. Right here, todos/3. I'll go back to like that weird one though. All right, next up, we are going to create a updateOne endpoint. So right now we can find them all. We can get one. We can create one. Now we want to update one. So that is going to look like this. So we'll say router.put. So if you make a put request to this specific ID, we're going to validate the ID just like we did with a get. But now we're also going to validate the body, and we're going to validate that the body is of type to-do. And then we're going to call updateOne. So you can see how our earlier refactorings are helping us now. We're essentially, now I can use this validation function to make sure that the incoming ID is valid and the incoming body is valid. And I'm specifically implementing a put request, which is replace the thing at this specific ID with the request body. You could also implement patch. Patch is usually you allow the client to send a partial object, so only send the content property or only send the done property. We could implement that as well, but for now I'm just going to implement put, which replaces the entire thing at that given ID. And so now we need to implement the updateOne function. So we'll go to our handlers. We'll say async, we'll export async function updateOne. I'm going to copy this and then update it accordingly. So the incoming request will have an ID in the param. We are going to respond with a to-do that has an ID. After you've updated it, we'll respond with it. And then the request body needs to be a to-do, because the incoming request is a to-do. And then we are responding with a to-do with ID. Great. So we've got our try, catch, call next with the error. Let's go ahead and write a failing test. So I haven't been doing that. Basically, we've been writing it and then just testing that it works. Let's write a failing test first. So we want, we're going to describe a put. So if we make a put request to some specific ID, we should handle both of these not found scenarios. So if you're trying to make an update to something in an invalid object ID, that should result in the same error. So now we're going to test with a put, and same thing here. So I know I've just copy pasted the test, but the one difference is now we're making a put request versus a get request. So there's that. And then if we make an actual put request with an update, let's do it in this one. So when we make a put request to this endpoint, it should, if it's successful, it should respond with a single to-do. And so we're going to make an update against the one that we created earlier. So that same ID. We should expect, can someone tell me what's the status code for when something is updated or replaced? For now, we'll just do 200. And we want to send an actual object. So we want to send, what do we want to update this to? In this case, we're going to update the content to be learn TypeScript, but we're going to set done now to be true because done was false before. 201 created. Well, if it's updated, is it still created? Regardless, so we'll expect it to have the ID, have a content property, and then we should expect done to be false, or to be true. .204 resource updated successfully. Good to know. So we'll do status code 204. So when I make a put request to my API at this given ID, and I'm sending the whole object, and I'm setting done to true, it should respond with the 204, and the done property should now be true. Let's run our tests. We should see a failing test. What's nice is we did get 2 extra passing tests out of that, the 2 puts here. Because we tested those the exact same way that we tested the gets for invalid object ID and not found. Expected 404 not found got 422 unprocessable entity. Unprocessable? 204 is no content? All right, well, we'll have to update this. I'll look that up in a second. I want to make sure that this is failing for the right reason. So put API v1 to do /ID. That is going to run here. And I guess right now, we're not doing anything. So it should just time out. I think that's the main issue. It's just timing out. Yeah, I mean, according to this Wikipedia article, I should just go for status code 200. So that's what I'm going to do in the test here. So this should be status code 200. Okay, first off, let's get the... so this one is technically working because the params validator is already... We already coded that earlier, and we could test that here. Now, we want to do this... Oh, I see. That's what... And okay, so I saw in the errors we got a 422 unprocessable entity. That's because we didn't specify a body in the not found one. So technically, if I were trying to do a put, I also would be sending some data along with that, like done... false or done true or something like that. Done true, content, learn TypeScript. So technically I would be sending that. This would get validated and then it would be a 404 not found. But right now this is just going to time out because my handler isn't doing anything. So let's handle the not found scenario. So we'll get back some result and we're going to await our to-dos collection dot. We're going to choose findOne and update. So this will search the DB for the thing. If it finds it, it'll update it. If it doesn't, we'll know what happened based on the response. So we need a filter. We're going to filter it the same way we did earlier. We're searching for a specific document with this ID. And then the updates that we want to make are set. So we want to set the properties from rec.body. So rec.body is the thing that we validated already, the request body, and that's what we're going to set those properties to. And then one last thing we need to specify here is what we want to return. And in this case, we want to return after, meaning return after the update is complete. So this will find it, update it, and then we get back that updated document. So here we can say result dot value. So value will be the updated thing if it exists. So if it doesn't exist, then we're going to throw an error. And we can reuse this error. Basically, we didn't find it, so and we couldn't update it, so it wasn't found. But if the result does have a value, then that's it. That's all. Basically, that is the updated value, and that's what we'll respond with. So we should be good here. No type errors. Let's do some tests. See what we got. Good to go. Great. All right. So the last handler that we need is the ability to delete one specific to do. And so it's gonna look similar to the put, except the method we're expecting is delete, and we're only gonna validate the request params. So when you're making a delete request, the body is completely empty, so we don't need to validate the body. We just validate that the incoming ID is a valid object ID, and then now we can define this deleteOne function. So let's do it. We'll have our async function deleteOne. I'm just going to go ahead and copy this, and then we'll update it accordingly. So the incoming request does have an ID, so that's correct. The response body is actually going to be, I think, just an empty body. And the incoming request body is also empty, so I'll specify it like that. And then the response responds with nothing. So we'll do a try catch. If there was an error, we'll call next with it. And why is this all complaining? Oh, I need to export it. Great. At this point, I'm going to write my tests first. And make sure we get some failing tests, and then we'll write the code to make it pass. So if we go over to our to-dos tests, I actually am just going to copy this put because it's going to be very similar. But this is now testing for delete. And then we want to test all of these same things, like does it validate the ID? If I make the request here, does it respond with a 404 if it wasn't found? Though, I do have to decide what's the proper way to respond to a delete. Like, do I always just respond 200? We'll see. We'll see. I think for now, if it wasn't found, respond with 404. And then responds with a 204 status code. So if I now do a delete at that given ID, we're not sending anything. There's nothing in the request body. We're just making the delete request. We're expecting that we should get back a 204, meaning that it was deleted. And that's the standard REST response for deletion. You don't respond with a body. You just respond with an empty body and a 204 status code. So what we also want is this. Cool. We'll run our tests. And it's gonna time out because right now that handler that we wrote has the try, but then nothing happens in the try. So both of those requests timed out, the 404 and then the actual deletion. So now let's make those tests pass. So we'll have our result, and we'll say await todos dot delete one. I guess if I do findOne and delete, it might be easier to make sure that it exists. Let's do findOne and delete, because that way we can write it in the similar way that we did findOne and update. Honestly, I'm going to copy these options. In here, we'll pass them in, but in this case, I only want that. Why is this complaining? Oh, so findOne and delete takes in a filter, a modify result. In this case, we're not trying to modify anything, so empty, and then we want that thing back. So I'll say if result dot, what does result give us? And actually, do we get this same option here? I guess in this scenario, we don't even care. There won't be an option for return document after. That makes sense here because we're not updating anything. We're just finding it. And I believe I can just pass it in like that. Cool. So just find it, delete it if you found it. Now, if result dot value, that means we found it and also means that it got deleted. So if there was no result value, we can do the similar thing we did before, where we set it to a 404 and send back the error. And then lastly, I'm just going to do res.send or res.status 204.end. So don't send back a response body. only a 204 status code that it got deleted and end it. And if the test passed, great, but I want to write one more test that makes sure after deletion, if we make a GET request for that same item, then it responds with 404 because it should be deleted at that point. Expected content type header field. That's my fault. So in the test, where I left this expect content type. In this case, there is no content type. We don't even need an except because basically we want to delete it and then just expect that we get that 204 status code. So let's do this. Great, fully passing tests. Awesome. But like I said, I want to write one more test that makes sure that after deleting, if we try to request that same to-do, we should get back a 404 not found. So I want this one. So delete it, and then if we make a GET request, we'll have to pass in that ID. We should expect a 404. And this ID needs to parameterize to be the one that we created earlier. Okay, moment of truth. So after deleting, we have to make sure that we get back a 404 and it doesn't exist anymore. Hey, fully passing tests. Awesome. That's it. I think we're done. We did it. We did it. In 3 hours, we built a CRUD app with tests, with models, with TypeScript, validations. We have route validations. It's good stuff. All right. A quick correction that was brought to my attention by Alka, and they mentioned, well, why are you awaiting find? You see those 3 dots right there? VS Code is saying it has no effect, which means find doesn't actually return a promise. So I made a mistake here, and if you look in the documentation for MongoDB, when you say find, that actually gives you back a cursor. And that makes sense when you're dealing with a database with a whole lot of data, because if you were to just do a select all or a query all, that could be a whole lot. You could run out of memory. It could take a really long time, which is why they give you back a cursor, and then you can go like one page at a time. In our situation, I know that there's not going to be that much data because we're just dealing with to-dos here. So I actually could change this to be todos.find.toArray and call that to-dos here. So if I make that update, now it makes sense because this is the cursor, and then I'm saying take all of that, turn it into an array, which toArray returns a promise, and then we get back the data there. So a quick aside, we should be doing it this way. Thank you for watching this video. Hopefully you learned something. And if you want to take a look at the code, if you go to the repo in the description, there is a branch called solutions. And if you go over to the solutions branch, this has the API that I just implemented. You can look at all of the code here, all of the things we wrote. You can take a look at it there. In a future video, we will do more refactoring. So we'll talk about things like data access layer and controllers and services. And in a future video, we'll also build a client for this API. So we're going to build a client with React and TypeScript, and we're going to do a little bit of refactoring so that way we can reuse some of the types that we defined here. And then we're also going to build a client with Vue and TypeScript. So again, hope you enjoyed this. We'll see you in the next one.